Assalamualaikum warahmatullahi wabarakatuh. Today, me, Ahmad Nabil bin Nazar, and my friend Nuvin Nadarajah, Afiq Zakwan, and Ahmad Nazirul will present an assignment with the title Free Body Diagram from Actual Structure. Next, Ahmad and Nazirul will introduce about this assignment.
Okay, first I want to introduce myself. My name is Ahmad Nazirul Mubin. So, the real structure that our group have been chosen for this assignment is a roof truss. Roof trusses are loaded of bearing frames which constructed of connected triangular shapes. Remember that from the triangle have pin type joint. This type of joint has the property that all the bending moments within the truss are eliminated. The members that making up the trusses are either in compression or tension, unlike beam structure which experience tension and compression at the same time. This is the reason that trusses are more efficient in supporting loads over wider spans compared to simple beams. So next, Nabil.
As you know, there are three types of support, which is pin, pitch, and roller. In this type of structure, the type of support is pin support. A pin support can resist both vertical and horizontal type of force, but not a moment. They will allow the structural member to rotate, but not to translate in any direction. Many connections are assumed to be pin connection, even though they might resist a small amount of moment in reality. In this structure, the load for each joint is 50 kN, 10 kN, 25 kN, 10 kN, and 50 kN at joint A, H, G, F, and E, respectively. All the load are distributed equilibriumly to the truss. Next, Ahmad Afiq will show you the calculation.
Okay, so my name is Ahmad Afiq Zakwan bin Zulkifli. Okay, now I will present about the calculation for each member to the towards the project that we have chosen for this task. Okay, first of all, we must determine the amount of joint for each members on the roof. So, the joint that we have determined is joint A, joint C, joint H, and joint B. And also, I add one special case for extra calculation, which is force at Z axis. Okay, so for the joint A, the members that is consists of force AB and also force AH, and plus the force reaction which is 50 kilonewton. Okay, so for the FY, we want to determine the force reaction at the AB, and the force FX, we want to determine the force AH. Okay, so for the next one is joint C, which is consists of uh, force members, which is CB and CD, and also the G, which is the reaction. Okay, so we determine by calculate for summation of Fy to determine the force GC. Okay, the next one is joint H. Okay, so for the joint H, the members that we have determined is HB, HA, HG, and also the force reaction at the H. So for the summation of Fy, we want to determine the force Hb, and the summation of Fx, we want to determine the force Hg. Okay, so the next one is joint B. Okay, so at joint B, there are several members, which is the most one. So it consists of BC, BG, BA, and also direction of H. So the summation of Fy, we have come out one equation, which is FBC. So this one we want to determine the FBG. So from the summation of Fy, we continue to the summation of Fx, and then we put the FBC to the equation Fx. So from there, we have determined the force Bg. So the last one is the special case, which is additional calculation for force at z-axis. The we have choose joint A, which is consists of AB, AH, and direction at A. So we use summation of Fy to determine the force Z. So that's all for the calculation. We move to the next part.
Thank you, Afiq, for the calculation explanation. Now I'll explain about the table of force that has been calculated from the calculation above. At the joint A, the force of FAB is 80.815 kN compression, and the force at FAH is 63.492 kN tension. At the joint B, the force of FBG is 105 kN tension. Meanwhile, at joint C, the force of FGC is 113.820 kN. In joint H, the force of FHB is equals to 10 kN tension. For the special case of Z-axis in point A, the force of Z-axis is 43.15 kN. As a conclusion, the support, reaction, and reaction forces of the chosen real structure, which is a truss, had been calculated through this assignment. All the data had been recorded and presented in the form of poster and recorded video. Therefore, the objective of this assignment has been achieved. We also achieved that the calculation, how to calculate the forces in the truss using the data given, and also how to draw a FBD from the real structure in this assignment. We also hope that we'll be learning a lot of things that regarding the static, FBD, and also the truss in coming years. Take care, stay safe, and thank you from us from BMMA S12. Thank you.